Hello! Okay, let's dive into our stats breakdown. We are going to use this time to really decipher through the articles that we read and to make sense of them so that when we have our actual discussion, this portion will be done. So the questions will be more focused on the formulas and the stats and how to make a great clinical judgment about what it is that we just read and to learn how to better critically appraise an article. So the one that we're looking at right now is addressing everyday challenges, feasibility of a family caregiver training program for people with dementia. Okay. I'm not going to go into detail about the entire article because we've read this. Plus, it'll leave some things for discussion. What I would like to do with this is to explain what it is that you're looking at so that it makes better sense. So the more tedious and repetitive we become in pointing out things over and over and over, things that you've learned and things that may be new, the better or the easier will become when you doing this on your own. And it becomes second nature, right? You know why there was a t-test. You know why there was an ANOVA or why it was used or why it was not. And you can make good clinical judgments from this. Was it adequately designed? Was it adequately powered? Was it statistically significant? Was it true? So that's why we're going to do this. And then we'll take the time for using Blackboard collaborative discussion or in-class discussion to just go further, okay? So I'm going to skip down to right down to the data analysis section because this is kind of where it all starts for us, okay? So this is page 215 of the article that we're looking at. Here's data analysis. So go ahead and skip down there and let's talk about this first paragraph. We used SPSS 19.0 to analyze the data at univariate and bivariate levels. Paired samples t-test to determine whether the program led to increased caregiver knowledge in each of the six ADLs. Post hoc power analysis using G-Power 3 with an alpha level of 0.05 two-tailed indicated that paired samples t-test for differences in means were adequately powered to detect effect sizes D equals 0.50. Now, I guess just to say, by Cohen's 1988 standards with a power of 0.99. Let's just pause there because that's a lot to take in, right? Whoa, what are you talking about? Let's talk about what they're talking about just to make sure that we're all on the same page. All right. SPSS is a statistical program that helps you analyze data, okay? So instead of doing everything by hand, this program is developed so that you can use the program to assist you with all of the formulas and calculations, that kind of thing. In this aspect, it's not really that important. Well, it is in a sense. It's good to know that they use it because it's something we can trust to make sure that they used an adequate program to complete their calculations. Okay, so in that sense, that's for now. That's why it's important. Okay, great. You use a program that is highly recommended and does a good job. Now, let's talk about this. They said to analyze the data at univariate and bivariate levels. What is that, right? Well, let's talk about it. So univariate accommodates one dependent variable, and bivariate involves or depending on two variables. So it's just essentially a difference in data. Univariate, you would use it to look at one variable in a data set to analyze or describe a scenario or experiment. So using a t-test or a analysis of variance, which is an ANOVA, right? While bivariate looks at the relationship between two variables. So it's an analysis of the two variables. And these can change and it can be compared to find the relationship. So if A influences B, it's most likely bivariate, okay? So in a sense, just kind of think there. Univariate, one dependent variable. That's all it's focusing on. One variable in a data set analyzed to describe a scenario or experiment. Bivariate looks at the relationship between two variables, and that can change and can be compared to find the relationship. Okay, so pointing out, again, why do we care about this, or why are they telling us this? Because they're telling us what kind of levels of data that they use. All right. Now, paired samples t-test. What is a paired samples t-test? Well, let's talk about what a t-test is first and foremost, okay? And I'm going to keep referring back to this little handy dandy chart that I provided you because it's a great tool. And until you become a master at knowing what is what, we're going to use this to refer back to. So on the second page, it says bi and multivariate inferential statistics test. Remember, this is inferential statistics. These are the inferential statistics used for this research study. They said they used a t-test. Okay, now that's important to know. Why did they use a t-test? Well, let's look at what a t-test is. Let's remind ourselves. T-test looks at a difference between groups on some variables of interest. So the IV, what is the IV? It's the independent variable. The independent variable must only have two groups, male or female, undergrad or grad, right? An example is, do males and females differ in the amount of hours they spend shopping in a given month? Well, let's take a look at what they're looking at. What are they looking at? What's their question? Let's go back up. The purpose of this study was to examine the feasibility and efficacy of the family caregiver training program for assisting with the basic activities of daily living of people with dementia. They used a one-group pre-test, post-test research design with a 3-month follow-up used to examine the efficacy of a manualized education program for caregivers. Okay? Now, that's also good to know. So we're going to go back down to page 215, and we're going to keep going. Now, save things for discussion as we talk, or as I talk, so to speak, so that we can make sure that you have a full understanding of all of this. So, here we are again. They used paired samples t-test, and a t-test, again, is used to look at the difference between two groups of some variable of interest. Okay, this t-test is a very common statistical tool that's used, and there are different kind of t-test, which this doesn't go into description of, but let's talk about it. Okay, we know that there's an independent unpaired t-test and that there's a paired t-test, and here they specifically tell us that they used a paired t-test. This is important. We need to know that. All right, now let's talk a little bit about a paired t-test. Okay, first and foremost, there are many inappropriate uses of a t-test. Okay, one is knowing, because it's commonly used, you have to know which one to use for what you're looking at. Secondly, sometimes people can fall into the idea that, well, depending on what they look at, they can just do multiple t-tests. And unfortunately, that's when it comes down to understanding of what the t-test is really for. So the sole purpose of a t-test is to compare two means. Therefore, when more than two means are analyzed within a single sample, the t-test is not the best tool to use. So if you were, for example, to compare 3 types of exercise, it would be incorrect to use a t-test because the analysis involves 3 comparisons within one sample. Now, why is that a problem, right? Well, the problem is when you use multiple t-tests within one set of data, is that more comparisons one makes, the more likely it is to commit a type 1 error. So that is to find a significant difference when there really was no difference. Okay? So we want to make sure, first and foremost, because a t-test is a very commonly used inferential statistics, that 1, it's appropriate, and then 2, that it's the correct t-test. Okay? So one of the things I want us to discuss is a reminder of what's their question? And then, are we only looking at 2 means? That's your question that I want you to think about for our discussion. Are they only using 2 means? All right. Now, specifically, they said they're using a paired samples t-test, essentially a paired samples t-test is just a paired t-test. But it's different, okay? Now, let's talk about a paired t-test. Why would they use a paired t-test? Well, okay, researchers often will use repeated measures or match designs to improve the degree over control over extraneous variables in the study. And these design subjects may be matched on relevant variables such as age and intelligence, or any other variable that is potentially correlated with the dependent variable. So sometimes you would see twins or siblings that are used for matched pairs when you're looking at paired samples. But more commonly, we use subjects as their own controls, okay? That is, what that allows us, what it means is we're exposing each subject to both the experimental condition and then comparing their responses across these conditions, okay? That means that they are paired. The data is considered paired or correlated because each measurement had a value matched for each subject. So, to determine if these values are significantly different from each other, you use a paired t-test because this test allows you to look at the different scores within each pair so that subjects are compared only with themselves or with their match. And I probably should show you what that looks like. Pen. I need a pen. So, now let's talk about this a little more. I know you've seen this, and you will also see it in the paper. So, for instance, I think that one in the paper was T52 equals some number, right? So for a t-test, for paired data, so t-test, or I should say, yeah. So for a t-test, we use a t-statistic. For paired data. Okay. The t-statistic for paired data looks like this. T equals D. Sorry, that's a D. Not a very good D. Let me change that D. Over SD. Okay? Now, what does that mean? D is the mean of the differences. So this is the mean of differences. In SD, this one, this is the standard error of differences. Okay, I'm going to pause here because I'm only going to do these videos in 15-minute increments, so we'll come back to this.